Class, we're on exercise 4.7. A boat sets sail from Harbour H and travels 7 kilometres due north to a marker buoy B. At B, the boat turns west 20 degrees south. Travels a further 8 kilometres before stopping at X. Calculate the straight line between H to X. So essentially, lads, you're looking for here to here. Okay, so you're looking for the line from H to X. Now, we're going to make a triangle. I'm going to make this black triangle here, might make this whole thing seem a bit more obvious to you. Okay, so do you see that black triangle there? Now, what's 20 degrees? 90 degrees take away 20 degrees is 70 degrees. Now we know the angle in between two lengths, and we have to find the length x. This is a clear idea that you're going to use the cosine rule. If you were to use the sine rule, the problem is that you wouldn't know two of the variables. Actually, I won't call it x if that's okay with you guys. I'll call it a. Okay, so if I was to use the sine rule, I'd choose sine 70 a over sine 70, and then I'd have to choose 8 over sine h. That wouldn't work because I'm missing 2 letters. So when you have an angle sandwich where you know 2 sides and the angle jammed in between, you're going to use the cosine rule. And let me write down the cosine rule. Now the reason why we're not using Pythagoras' theorem is it's not a right angle triangle, so that won't work. Okay, so we're going to have to use a Pythagoras theorem, right? So a squared equals b squared. So call b squared 8 squared, c squared 7 squared, minus 2bc, so minus 2 times 8 times 7, cos 70. Going to put all that into the calculator. Make sure your calculator is in degrees mode. So what I mean by that is make sure your calculator, see the D at the top, so you go shift setup and make sure you're in degrees mode, okay? And then you're going to do 8 squared plus 7 squared minus 2 times 8 times 7. Then you're going to do cos 70. Put that all into the calculator and you get a squared equals 74.694. 37 rounds up to 40. So what's it again? 74.694. 74.694. We're going to square root that answer to get the result we're looking for. So root answer, or root 74.694. Yeah, 8.66 to 2 decimal places, because 58 would round up to 60, so the 65 rounds up to a 66. 8.66 kilometers. Right, so that's question 1 done. Now we're on to question 3. A snooker cue cues the white ball. So here's the white ball. It goes in a straight line 85 centimeters, hits the cushion, makes an angle of 88, hits the red ball, it then returns back to where it began. Calculate the total length it traveled. So the first thing we're going to have to do is we're going to try and find out what is the length of the yellow side here. So once again, we seem to have an angle sandwich, which we're going to use the cosine rule. So call this A. So we're going to use a squared equals b squared plus c squared minus 2bc cos a. Okay, and then we're going to use a squared, which is a squared b squared. You can b or c can be 85 or 30, whichever one you want. So 85 squared plus 30 squared minus 2 times b, which is 2 times 85, times c, which is 30, cos 88. (85 squared plus 30 squared minus 2 times 85 times 30, cos 88. And 7,947.01. 7,947 point, what's it, 01. So that's 01. We're going to square root this to get our answer, 7947.01, and we get 89.146, or just if we reread the question to the nearest centimeter, 89 centimeters. Now the problem here is that 89 centimeters is actually not the answer. It's actually 85 plus 30 plus 89. So 85 plus 30 plus 89. Put all that in. I believe it's 204 centimeters from having done it in previous years, but we'll see now. 204 centimeters. That's our answer for question 4. Or sorry, question 3. So now we're on 1, 3, and now we should be on to 5. Now, a goal post on a soccer field are 80 meters apart. The player kicks for goal when he is 30 meters from one post and 25 meters away from the other post. Find the angle opposite the goal line measured from both goal posts to where the ball is positioned, correct to the nearest degree. It's an angle question, and we're going to call this angle A. We can't use the sine rule, because if you were to label all three angles A, B, and C, you'd have to use 25 over sine C equals, 8 over sine A. You see the way you don't know two of the letters? So no matter what, you won't be able to use the sine rule here, because you need one letter missing, not two letters missing. You can't use Pythagoras' theorem or SOHCAHTOA, because you're not really guaranteed to have 90 degrees there. So you're going to have to use the cosine rule, which is a squared plus b squared plus c squared minus 2bc cos a. So a squared is 8 squared, b squared plus c squared, which is going to be 25 squared plus 30 squared, minus 2 times 25 times 30 cos a. Now this is an angle question, which makes things more difficult. You have to corner off this section here. This section here has to be treated specially, okay, because it's bound by multiplication. So what you're going to get is 64. 25 squared is 625. So we have an angle question. So we have 64, 25 squared, 625, 30 squared is 900. Take away 2 times 25 times 30. Times 30. Yep, minus 1,500 cos A. Now we're going to move we're going to move everything to the left, so it's going to be 64, take away your 625, take away your 900, equals your minus 1,600 cos A. Oh, sorry, 1,500 cos A, my fault. Now, you might be asking, what are you doing in this question? Well, you're trying to find out the size of this angle. So you got to get cos A on its own, and once you get cos A on its own, then you can get A on its own. Now we're going to add these together. So see the 64, take away the 625, take away the 900, and what you're going to get there is minus 1,461. That equals minus 1,500 cos A. Multiply both sides by negative, turns both sides into positives because they're already negative. You want to get cos A on its own. Multiplication of 1,500 on the right will be division of 1,500 on the left. Now you're going to cos inverse that. So to separate cos from A, use the button shift cos. Cos inverse 1,461 divided by 1,500. And what we're hoping you get out of this is you get 13 degrees, okay? So A equals 13 degrees. Because you said A equals cos inverse 1461 over 15,000. Or sorry, 1,500. Okay, everybody happy with that? So that's question 5, 1, 3, 5. And now we're doing 6, 1, 3, 5, and 6. The third hole on the golf course is 470 meters long from the tee. The ball had been driven at tee a distance of 260 meters. However, the drive is 70% off the line hole. So imagine this a helicopter's view from the top. You want to go directly to the green, but obviously you went 10 degrees to the left. How far is the hole from the ball correct to the nearest meter? So what you got to do this time is you got to find the distance from the ball to the green. And once again, we got a cosine rule here, where it's going to be a squared equals 260 squared plus 470 squared. You can say that's a B and C. And we use the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos A. Then minus 2 times 260 times 470. The angle in between, which is your 70 degrees, cos 10. This is a length question, because we're trying to find out the length of the black length there. How long is it to the hole? So we can do 260 squared plus 470 squared minus 2 times 260 times 470 cos 10. And then there is 47,812.985. 47,812 and then 0.985. Got to square root that. Square root 47,812.985. Square root tells you what it is on its own. And then 218.66. Because a squared means you square root the other side. Correct to the nearest meter. Well, that'd be 219 meters. Okay, we're done. So